So once again, thank you to all of you for joining us today. We started out today's conversation with some sort of almost conceptual ideas of the migration path from legacy to software-based operators. We're going to continue that conversation, now getting a little more specific into how some of that might happen, and more specifically, some of the challenges that the community is going to face doing that. Before we get to that, a couple of notes. Following our session right now, we're going to be serving lunch. Lunch is going to be served buffet style just outside this room. The one thing that I ask is that you try to get your lunch, come back in here as quickly as possible. We've got a great keynote lined up during lunch from IBM, so really looking forward to that. Also, again, as Paula mentioned, you've got speaker evaluations. Certainly appreciate your feedback on any and all of the sessions that you're participating in today. And at all of our breaks, don't forget our exhibitors have booths set up across the lobby. A quick bit of introduction. I'm Eric Lenask, the Group Editorial Director at TMC. Look forward to hearing from any and all of you if you have comments or questions. Most importantly, I do want to point out two specific sites that we manage and maintain that are very relevant to today's discussion. One, our nfvzone.com site, obviously focusing on network functions virtualization and the concept of the software telco. And the other is SDN Zone. I encourage you all to visit. And certainly if any of you have contributions to those sites that you'd like to make, feel free to reach out to us at any time. So as I mentioned, we're going to talk a little bit now about some of the challenges facing the industry. We know that security, scalability, resiliency, those kinds of things have been traditional deterrents, especially when we've talked over the last several years about migration to virtualized environments and the cloud and things like that. But what we're doing now is we're telling the telecom industry and the service providers that they need to virtualize and they need to cloudify, to borrow a term from Cassidy's presentation earlier. So those questions are what we're here to tackle now. I'm joined today by Glen Gerhard. He's the Vice President of Product Management at Sansay. And by Nabil Mooney. He is the Senior Director of Strategic Marketing at Netronome. I'm going to let Glen and Nabil introduce themselves in a moment. Actually, each of them has a short presentation lined up for you, after which we're going to go into a more traditional Q&A session. At any time, if you've got questions, raise your hand, shout it out loud. Certainly welcome any and all of your questions. So with that, Glen, actually, I'm going to hand it over to you.
Okay. Hi, my name is Glen Gerhard, the VP Product Management at Sansay and one of the early employees there. Prior to that, I was the VP of Business Development at a company called New Era Communications. Also worked at a Silicon Valley firm called NET a few years back. And prior to that, I was a graduate from Ohio State University. So the kind of the basis of the talk here is security and resilience. And resilience is basically a discussion of how you adjust a network to either a load and an unexpected outage, topology change, or an attack from somebody trying to bring down your services. So kind of using that as a background, from a security perspective, a lot of the virtualization solutions aren't that terribly different than the TDM world. Although in the TDM kind of traditional telco world, you used to have a much more static, locked down signaling network. So the primary signaling in the TDM world was SS7, and to get into an SS7 network, you had a tremendous amount of paperwork and logistics and cost associated with that. Now in the VoIP world with SIP and IMS, that can be a much more dynamic interchange. It's not a carefully controlled signaling protocol that SS7 was. And that's important. It provides a lot of value, but it does make the transition from the TDM world over to SIP and IMS, somewhat more challenging from a security perspective. In the old TDM world, security was basically, your fireproof, your COs and things of that nature. But in the VoIP world, it's a world of denial of service attacks, fraud, things of that nature. But when you move to the cloud, again, it's a different level of complexity in that you're moving to another layer of abstraction. So in the VoIP world, you do own generally your infrastructure, and you can have your own dedicated hardware, dedicated, they may be virtualized, but they're your systems, and you're running them within your sites and able to control the configuration very minutely. In the cloud world, it's actually something else, somebody else's hardware that you're running on. So you're on their network with their firewall and their hypervisor, and you're generally going to be a tenant within that system. That produces a fair amount of challenge there to make sure that you're able to achieve the same type of security from that perspective. In the early days, there were some issues with hypervisor security where you can have cross-tenant attacks and things of that nature. But I think those have basically been mostly taken care of. But again, it is a matter that you're no longer in charge of that firewall. That firewall is run by Amazon. The switch is run by Amazon. The physical systems are run by Amazon or Terramark or whatever cloud vendor you're running with. And then that can produce a little bit more complications. You used to only have to be worried about the OS of your system and the vulnerabilities that may have. So from that perspective, now you have another level of devices that you're worried about in terms of their vulnerabilities. From a term of resiliency, the VM world really can be made very HA and fault tolerant. So even if you're running in a cloud, you can have the same high availability applications running on those VM clouds. It becomes a little easier and cheaper as you really can spin up a new HA system. And if that physical system dies, you go over and you spin it up again on another platform, and you're back into your protected HA realm of operation. So I think that can be as reliable and fault tolerant as a normal deployed hardware-based system. But essentially, you're going to have your route plane, you're going to have your session processing plane, and your media handling plane. And those are going to be either co-located or distributed in many different locations. So as far as resiliency, the distributed nature of cloud computing, such as an Amazon or Terramark would give you, is that you can bring up new adaptive capacity as you need. One of the questions is, as Rich mentioned today, you can't burst a class 5 switch or a class 4 switch. But I think one of the questions is, how adaptive can your network really be in terms of saying, okay, I have a site that I'm expecting maybe 10,000 sessions to flow through. Suddenly that's now at 50,000 sessions. Do I bring up another instance? Do I try to redirect that traffic to another site? How is that actually managed from a capacity perspective? And then from a perspective of security, it's going to have a lot of the same requirements that you have today in your standard TDM type of network, where you're going to still need the fraud detection, you're going to need the firewalls, you're going to need the intrusion detection. Things of that nature are going to be essentially the same type of paradigms that you are using today. The BSS and the OSS is going to be dramatically different, but from a security perspective, most of those things are hidden from the actual interface to the cloud carriers themselves. But I would say the amount of troubleshooting that goes into a NFV cloud-based network will be quite complex. With the flexibility that the NFV gives you with middleware, distributed applications running from different ecosystem partners, when you have a problem in that type of network, you're going to have to have a very detailed way to troubleshoot, okay, I'm having an overload on a system. Is that overload caused by the middleware? Is it caused by an application? Or is it caused by an external event such as a bad infrastructure or a malevolent DOS attack or DDoS attack? So I think the troubleshooting techniques need to be really refined in order to provide that level, the level of security and resiliency that people are used to.
All right, thank you, Rick. Thank you, Glenn. So good morning. I'm Nabil the Mooney. I had to travel quite a bit to get to this conference. We're actually on the 4th floor of this building. So I'm glad to be here because Netronome is at the intersection of SDN and NFV combined. And I'm going to try to explain to you how does that happen and where we are in the process. So I work for Netronome, but I'm also the vice chair of the market education at ONF, which is the Open SDN house. I'm also the editor of the compute domain in ETSI NFV. So I'm going to try to zip through the slides because the intent here is to be Q&A and not so much slides. So I'm going to talk a little bit about who Netronome is. Layer 4 and Layer 7 usually are where the security appliances and middle boxes are. So I'm going to focus on what we did there at ONF from Layer 4 to Layer 7. And then I'm going to talk about the advantage of having DPI, for example, in the infrastructure layer, and show that NFV is really complementary to SDN. I do, unfortunately, disagree with some of the panelists earlier. We are not going to break away from the hardware. That's not going to happen. You're not going to run service chains on a Dell Power Edge or an HP ProLiant. That's not going to happen. Faults and resiliency, and then summary. So Netronome is a fabless chip company, and we license the technology exclusively from Intel. Intel decided to get out of network processors. We took that over 5 years ago. We have our own chip, which is a flow processor. So we did everything in flows and stateful manner. So we are a very good fit for security appliances and server-based infrastructure. Our next chip is going to be fabbed on Intel 22 nanometer. It will be out next quarter. It's going to be a bang-up chip, 48 10 gigabit ports, serving 4 Xeon processors, most likely Haswell at that site. So we did a study at ONF regarding Layer 4.7, and I led that study. The thing is that OpenFlow has been focused on Layer 2 and Layer 3 and some Layer 4. So all the 40 matching fields actually are concerned with the lower layers. There was really not much concern or catering toward the higher layers. And that's where really the security appliances fit, and that's actually where NFV fit. So we looked at the various services strategy here. We categorized it into 4 categories. I think the bottom category is the most consuming of processing power. So whether it's an antivirus, anti-spam, intrusion prevention system, intrusion detection, SSL inspection, VPN, this is all Layer 4.7. All these require for the box or the function to look at the traffic in a flows manner and to maintain state for those flows. You also have, of course, load balancers, next generation firewall, where you only need to look at the first few packets of a flow, and then you need to cut through the rest after you learn what the flow is about. So we looked at deployment model for this Layer 4 to Layer 7. On the right side is the ONF framework, if you will, where you have the network controller in the middle. This is the reference point. Anything above that is called the northbound interface. Everything below that is called the southbound interface. ONF has standardized the southbound interface to be open flow. They're just starting. We're having a meeting yesterday and today to kick off the northbound interface. But we said that layer 4.7 cannot simply be an application up there in the application layer. This can work for some applications like DDoS. However, for a next generation firewall or for an IPsec or any of those, you actually need to push that intelligence down in the infrastructure layer. So we see different classes of switches. Some will be dumb and fast. Some will be more intelligent. So I'm not sure if we went to sleep or... So let me keep going. Just my little bit on NFV and SDN. NFV is about virtualizing specific platforms. I can take a firewall, a residential gateway, an EPC for wireless core, a session border controller, a BRAS, and so forth. And it's a low-hanging fruit. And that's why, even though NFV started way after SDN, people are actually going and doing something about it because I can virtualize individual platforms. SDN, on the other way, is about network virtualization. It's about looking at all of these virtualized platforms, having a centralized control and management function, having a bird's-eye view of the network, try to rearrange the topology of the network based on some traffic conditions. So we say it is network-aware applications and applications-aware networking. So they're very much complementary. They do not compete whatsoever. Thank you, Rick. So anyway, there are different models. We said they're going to be in the infrastructure layer down here. They're going to be dumb devices that are layer 2, 3, just open flow switches. However, they're going to be much more intelligent devices that have layer 4.7 capability. So in much the same way today with the switch and router, I can insert a service card to do the higher layer intelligence. The same thing would happen actually for open flow switches. This is back to what Cosmos was doing, is if I put layer 7 intelligence down in the infrastructure layer, then I can actually distinguish between the various services in the traffic. So if I have video optimization on the far right, I only need to look at the video traffic so that I do not have to actually exert my processing power or bandwidth. So I only offer the video traffic to the video optimization. This is our view of the data center. In the middle, you have the SDN fabric. These could be the dumb open flow switches. All the intelligence is actually at the edge. So whether it's the security boxes below or whether it's a gateway server, all of them actually controlled under open flow. Now you see all of these edge devices can be NFV because they're x86 based. They can be virtualized. I can run all these applications as a VNF or a virtual network function. We looked at failures. So I picked that slide from the reliability group within NFV. So there are obviously different fault levels when we virtualize. The application itself can fail. Obviously, it can crash. It can overload. The VM itself, the virtual machine can fail. The core can fail. The hypervisor, the whole server, the physical infrastructure can actually fail. So what we are taking on with NFV is that the carriers now are convinced they cannot design 5 nines systems. That's not going to happen. It's too costly. Instead, they're going to design for failure. What does design for failure mean? Well, I admit that I'm going to have failures. How can I do failover? How can I do port redundancy? How can I do dual homing? And so forth. And this is a much less expensive proposition. Again, with Netronome, we build chips. We build PCIe cards. And we actually build a whole reference platform that has SDN OpenFlow 1.3, which is the latest. And because we are x86 based, we can host multiple applications, whether it's firewall, IPS, IDS, and so forth. Again, this is more stuff, but I think I should stop at that.
Great. I think we'll take just 30 seconds to move these chairs back up here so we can get into our Q&A. Are there any questions out there while we do that?
Thank you. Let's go. Thanks.
So, Nabil, I want to get to one of the points that you just finished up with, and really, you talked about planning for failure. What's the difference between that and trying to achieve, as operators traditionally have, trying to achieve 5 nines or some even greater reliability?
No, that's a good question, Rick. So I think part of the CapEx and OpEx problem that the telcos are realizing, I mean, when they look at, for example, Facebook and Google, they don't have much redundancy. They actually have spare boards, and they actually design things. They know it's going to fail. And they either manage it dynamically to fail over, or they actually manually do something. So in the old days, well, current days, the 5 nines, what does that mean? I have to have full redundancy, not N-to-1. Actually, I can have 1-to-1 redundancy. How expensive that can be. I should be NEBS compliant, which is, well, on the verge of being resilient or not. So there is so much overhead there. And when we talk about NEBS in NFV, I mean, it doesn't really even come up. All right, the operator want to move. We talked about over-the-top guys. The operator for the last many years has been trying to get away from being a pipe provider. They are more of a pipe provider today than they have ever been. And they're trying to get out of that. So the 5 nines can't go through all the details, but design for failure, meaning that I know a VM is going to fail. So how can I have my management and orchestration layer, call it the MANO, to actually switch to another VM, whether it's on the same core, or whether it's on a different core in the CPU, or whether it's on a different CPU socket, or whether on a different server, physical server platform altogether. If I'm doing service chaining and my whole chain actually fails, can I actually move the whole chain over to this other resource? I mean, these are the kind of things, these are new things that need to be considered, and they are not as cost burdened as what is being done today.
Yeah, obviously, I think the ability to expect hardware and software to fail is a key portion of rebuilding that service chain. Most of the failures that you'll probably see are going to be actually in the software. It's, hardware failures are pretty predictable, and they're easy to hot standby hardware. But if you have a severe software failure on one of your critical elements, that's where you're going to have potential downtime. But really, I think the expectation is that you're going to have that type of event, and you have to have a very detailed way to adjust and correct for that type of system or failure. But you may recall, I don't know, 15, 20 years ago when AT&T had this gigantic failure through, New York and the Northeast because they were doing a software upgrade on one of their SCPs. And that's the kind of outage that as we go to an NFV solution, we'll have to be very careful to make sure that we have the checks and balances in place when we're upgrading some part of the NFV software chain and it causes an interaction over here that was unexpected. We have to be able to plan those and roll back those very quickly.
What does that mean then in terms of service expectations?
So obviously you need to continue to meet the SLA and the service uptime. And again, it's really a philosophy about how to architect, how to design and architect the system. If it is 5 nines, what I'm saying is that they're never going to be a failure, or they better be not a failure, otherwise I'm going to be tanked. Design for failure, meaning that I know they're going to be failures. So I will have all these backup mechanisms to make sure that the service uptime is there and the SLA is being met. So it's really a mindset of how to go about it from the start and not to scramble when a failure happens.
Yeah, I would think that the end user, the customers like us, are fairly adapted now to a much less reliable network, you know, whether it's voice or data. But I think it should not be hard for us as the telcos to really create the environment that, sure, there's maybe an outage, but it's going to be a contained event that is adjusted for in a matter of minutes, so that, you know, your call may not be maintained as I go from this BGP conduit to that BGP pipe. It's 30 seconds for that network to reconverge to a new path, but it's going to reconverge and your subsequent calls or data will work.
Yeah, so one of the things we're doing, for example, is, I mean, dual homing. Dual homing have been in existence in networking for quite a while, meaning that the server actually have ports going to different switches or load balancers, and if things fail, I can accurately recover and fail over. You have dual homing, you have multiple ports for redundancy. It could be active standby, it could be active-active. All of these things that are more of a networking things need to be applied into the telcos, if you will, for this mentality for design for failure.
Assuming that, then is it easier and is it less costly or more so designing for failure, as you say, or designing for reliability, as operators have done in the past?
Well, I would say in the world of NFV, you're really forced into designing for failure rather than reliability. Everything's virtualized, and it's not a static system that you can control very granularly. It's a much more dynamic environment, and as far as cost, it's going to be easier to do it that way, and it's going to be the most effective way.
Yeah, I would agree. Actually, that concept, design for failure, was introduced only in middle of October at SDN Open Flow World Congress in Germany. It was Dave Meyer from Brocade, who is also the head of Open Daylight. And he's a networking guy. He's an IETF guy. He said, guys, I mean, I don't think it's realistic to expect 5 9 systems based on NFV and SDN. We certainly need to design for failure. We need to realize that there are going to be failures and try to plan for how to get around them and how to recover.
I have a fundamental confusion here. I mean, if you're designing for failures, I mean, are we not effectively designing for 5 9s? I mean, isn't that the whole goal? That the end customer shouldn't see a breach of service, right? It doesn't really matter. If we design for failure and we recover from it, then as far as the end guy is concerned, they're not seeing any change.
That's the beauty about it. I mean, it's really a philosophical, architectural thing. So now that we are virtualizing things, as Glenn mentioned, you have VMs. VMs individually can fail, or VNFs, the application itself, can fail. How can I actually move that over without actually the end user even experiencing a downtime? So the net effect is the same, but the mentality of how to implement and plan for it and architect the system is different.
Okay, so that means we're saying we are inherently working with systems that have 3 9s reliability, but we are doing something, and we know they'll fail, so we'll do something to tackle that failure so that in effect the user sees
Exactly.
5 9s or whatever, but our whole philosophy of how we are doing it is now different.
Exactly.
Thanks.
It's a great point, thank you. What does,
There was a question.
sorry, yes, sir.
Parts of your systems that can be virtualized, are commodity clouds like Amazon seems being good enough now for things like network connectivity, or would you still be deploying your own clusters of VMs and stuff to run this thing?
I'm sorry, can you speak up a little bit?
For the parts of your systems that you can virtualize, are commodity clouds like Amazon seen as being good enough, or would you still want to run your own systems, clusters of VMs yourselves?
Well, I'll let Nabi take that one because he may have a different view on it.
No, I mean, Amazon has worked quite well, obviously. I'm sure they have their own redundancy. I'm sure they have their own failure recovery because they wanted to maintain the uptime. So NFV, as I think Christos mentioned, you can have virtualized platform or you can have physical functions. It doesn't have to be virtualized. In fact, Facebook doesn't virtualize their CPUs. So whatever makes sense, the main thing is that the two will be coexisting. The two can work in harmony, and the two can actually deliver the intended SLA. I'm not sure if I'm answered your question, but
Yeah, and I would agree with that really from a cloud perspective, the Amazon world is something that can be designed into a reliable network so that the functionality can be distributed and can be essentially an HA instance backing up another instance so that when there's a failure, this instance will take over. Then you're going to have to, I think the idea would be to have some sort of automated process that resubstantiates your backup system now somewhere else so that you're not losing your redundancy. You don't have to manually go in and do something. That orchestration and automation is probably to be determined and developed still, but the underlying architecture is perfectly suitable for it.
So I want to go back briefly of why the hardware is not going away and why Cisco is not going to go out of business. It's not a secret that Huawei is driving so hard in the NFV arena because they see that as an inflection point. But to believe that Huawei is doing this because they're going to exit the hardware business, it would be a big myth. It's not going to happen. Many of these functions are actually growing in performance requirements, the service chaining, the number of ports for redundancy. All of these actually will require some underlying hardware acceleration, I/O virtualization, and the like. So yeah, maybe there are going to be residential gateways. That's probably going to be, it's called vCPE now, that certainly would not require any acceleration. It would be just an x86 or an ARM multi-core processor. However, many of the higher performance functions, whether it's a next generation firewall that needs 400 gigabit interfaces and such, that would certainly be accelerated hardware-wise. So what the NFV folks now are talking about is not just using COTS server, which is commercial off-the-shelf server, but it's a COTS server architecture. As long as you maintain the architecture, meaning that if I use an x86 general purpose CPU, running Linux OS, running KVM or Zen, open source hypervisor, and then I have some sort of network interface card that does I/O virtualization, that does the underlying acceleration, maybe encryption, decryption, and so forth, then that fits the bill. That is a COTS server architecture. I can carry that over into open compute platform that Facebook is doing. I can carry that same concept over to the IBM Blade system or to the Cisco Nexus server platform. So don't think of a COTS server that I'm going to just use a desktop server and this will do everything for me. Just a side comment to spur any more questions.
I want to touch on one thing that what is all these this potential for virtualization and moving into just a pure software environment mean for something that I think has challenged a lot of the operator community for a while, and that's the idea of federation and interoperability between carriers. Does that make it easier for them?
Well, it's going to be a much larger mixed vendor environment, especially now that you decouple the software from the hardware. And for example, for federation, if you want to implement a multi-SDN controller, maybe one for a local, one for remote long distance, then you need that interoperability. I don't think it's going to be any easier. It's going to be as challenging, if not more. However, from my reading, is that the carriers now are trying to create an ecosystem of ISVs, independent software vendors, that can actually write to these VNFs, the virtualized network functions. And they say, well, we're going to encourage innovation, we're going to go to startups and this and that. And on the other hand, they say, well, can we get the support we needed? Can we get the maintenance we needed? Are they going to guarantee interoperability? If I have a problem, is it going to be a software problem or a hardware problem? So I think it's going to become more complex, in my opinion.
Yeah, I don't know how it will necessarily impact the NFV infrastructure directly. I kind of viewed federation more as a signaling and authorization layer problem, where I want to be able to get a phone call on my cell phone from somebody using my Facebook account, or my email as an address or something along those lines, so that the federation is a logical entity that this group will communicate authentication and signaling on behalf of their users to this other group. Maybe I'm looking at that different than what your question was.
If we don't, we've got a question over there in the back. Yes, sir.
In this whole virtualized environment, we have the VNFs, which are now being looked at as coming from multi-vendors who build innovative apps and stuff like that. There was reference in a past session on this becoming similar to like the App Store kind of concept, where you have apps coming in. Wouldn't there be a need for some kind of certification process to maintain secure apps that are sort of onboarded onto these systems? And in execution, would there be some need for authentication and basically making sure that you have secure apps in execution?
Oh, yeah, absolutely. From a application perspective, if you layer on a new application, it's going to have to be built in now to your middleware that allows that execution. And I think before any carrier would allow that to happen, they would have to do considerable amount of testing on that new application, even if it's like speech rec or something like that. They'll do a tremendous amount of integration testing before they allow it to be accessible to their customer base and through their middleware. So they have to create that conduit and connect it so that the NFV users will be able to get to that application to begin with. So it'll be tightly controlled until it's proven out.
Yeah, so I would agree. We talked about ecosystem. I think each carrier is going to have their own key ecosystem. They know what hardware. We talked about a focal vendor that they're going to actually focus on. I'm sure there are going to be more. But they want to make sure that that ecosystem of ISV providers, of VNF providers, actually works well with their choice of hardware. This is going to be part of the integration process. So, the carriers have to change quite a bit. The internal structure of the carriers have absolutely need to change. And to me, they are very confused about how to go about it. I actually talked to the key guys firsthand. They're very confused. And my synopsis of that is that they're looking at it in 3 phases. They want to be able to crawl, and then walk, and then run. What is crawl? Crawl is I want to take an individual platform, like an SBC or a BRAS. I want to virtualize it, and I want to make sure it runs. Walk is, does it meet the performance? Does it interoperate with other legacy or NFV-based platforms? Run is, well, it might be time to add SDN to help in interconnecting VMs. Because one of the challenges in NFV is that I'm going to be spawning hundreds, if not thousands, of virtual machines. There must be a way to interconnect these virtual machines together. And if I tear them down, I have to tear down the connection. And that's where one of SDN's main priority is to provide that interconnect between those VMs and tear down the connection when it's not needed. So I think it's phases. I talked to carriers that their management already presented the big thing, domain 2.0. We're going to march toward SDN and NFV. However, if you talk internally, they are in a daze how to go about it.
And I think we have one last question for this session right here.
Thank you. Yeah, I have a question that focuses around the economics that's driving the network function virtualization, software-defined networking, and then the orchestration around all of that. It's a very complicated thing, as we're all talking about today, and it's kind of a one-off custom. There's no standards, and doing an orchestration engine that doesn't exist today in a multi-vendor environment, to spin up virtual machines, to put network functions in that virtual machine, and then route traffic to that on an ad hoc basis seems to be a very complicated, costly step. So my question is, it's an IT framework, really. That's what we're talking about. It's not a network function. It's really an IT approach and framework that needs to address this. Do you think that they're going to just build a very complicated, is their OpEx going to increase as a result of this thing, or are they going to really realize the business benefit?
So if I may, and then there is no question that management orchestration are key and OpEx is key. But OpEx, you can look at it in two different ways. How much does it cost me to run my network and my service? And I think the most important thing is time to service. And time to new service, time to new revenue. How can I deploy new services very quickly? And that's really part of the big value proposition of NFV, and it could be lumped under OpEx. It's not so much CapEx. But instead of taking me 2 years to offer a new service, if it takes me 3 months, can you imagine how much additional revenue would that be? Now, the management and orchestration, obviously is very key, and that's why there are 3 major groups within NFV. One is MANO, one is VNFs, which is the software applications, and one is the infrastructure, which is the compute, storage, and network. So MANO has been realized as a key thing. Now, does this a plug-in to OpenStack? Is the SDN controller part of the virtual interface manager and so forth? That's all being worked out, but I can guarantee you it's not being ignored because it's very key. And I do understand it's more of an IT model than a telco model.
Yeah, I would say certainly the applications aren't there yet. It's going to take quite a while of testing and development for that to really become a reality. But the cost, the expenditures are going to shift over onto the IT side to do that integration and testing and deployments. And the rest of the infrastructure, the spending is going to go down. There's no doubt about it. So it's probably robbing Peter to pay Paul for the time being, but long term, it's going to result in quite a bit of savings for the carriers.
Glenn and Nabil, thank you very much. If you have additional questions for either these two gentlemen or any of our speakers or sponsors out there, I certainly encourage you to visit them at their booths during some of the breaks and during the reception this evening. Right now, we're going to have lunch served just outside these doors, and as I mentioned earlier, if you don't mind grabbing your lunches coming back in here, we've got a great keynote coming up next from IBM's CTO of Telecom, Dr. Craig Farrell. Thank you, gentlemen.